Okay, we're going to go over the test review answers. Okay.
My turn or test review? So.
A piece of metal is heated and then submerged in cool water. What happens to the water? Water gets warmer. Temperature of the metal gets cooler. If the heat is released in a chemical system, where does it go? It goes to the surroundings. So the surroundings will absorb, the system loses. Endothermic, okay, absorbs the heat or energy. Here was that question from the quiz. Okay, question 4 here. The amount of energy needed to raise the temperature of 1 gram of a substance 1 degree Celsius. Question 5 seemed to bother a lot of people. Okay, but if you've only got 3 calories and you burn it leaving nothing, how many calories could you have produced? 3 calories. Okay, it's all that was there. 6 was on the quiz. Okay, it was different numbers, but how do you get from calories to joules? You simply multiply 127 calories by the 4.18 joules per calorie, gives you 530.86 joules. 7, okay, Q equals MC delta T. 300 times the 0.21 times the 15 degree change. 8, solve for C. 1560 is the Q, 312 is the mass, 15 is the delta T. This actually was the question on the quiz, folks. The exact same question, same numbers even. Answer 0.333 calories per gram degree Celsius. So if you had done your review ahead of time, you should have recognized this question. 9, how many calories? Again, Q equals MC delta T. 325 is the M. 30 degrees is the delta T. Oh wait, 30 to 100 is the delta T. So delta T was 70. 0.21 is the C. Multiply the 3 together. What are the units for specific heat? Calories per gram degree Celsius or joules per gram degree Celsius? Eleven is similar to question 8. Okay, it's just that we're in calories this time, or excuse me, joules this time. So we have Q, 956 joules. We go from 25 to 37, so the delta T would be 12 degrees. Mass of 45 grams. So 956 joules divided by the 46 grams divided by the 12 degrees Celsius gives us our specific heat. Note that the units, joules per gram degree Celsius, that's what we had in question 10. 12, okay, we're right back to Q equals MC delta T. This question was on the quiz. Different numbers, but this question was on the quiz. 5.37 grams times the 0.24 calories per gram degree Celsius times the 4.5 degree change. And then if we want to go from calories into joules, times 4.8 joules per calorie. This question again, 13, on the quiz. During a phase change, temperature does not change. How many calories are in a kilocalorie? 1,000. Kilo, 1,000. Food calorie. Food calorie is a kilocalorie, so there are 1,000. Exothermic, process that gives off or releases heat. 17 and 18 directly out of the book, chapter 17. Heat of fusion, the heat absorbed by 1 mole of a solid substance as it melts to a liquid at a constant temperature. By the way, this equals the heat of solidification, however, opposite sign. So on that one worksheet, we changed it from positive 333 joules per gram to negative when we were freezing. Heat of vaporization, amount of heat necessary to vaporize 1 mole of a liquid. And again, heat of condensation, same as the heat of vaporization, but a negative sign because it's got to lose heat to condense. Gains heat to vaporize. So, again, vaporizing, endothermic, because it's got to gain the heat to become a vapor. Condensation, exothermic, it's got to lose heat. Same thing in 17. Melting has to gain the heat, so it's a positive number. Freezing has to lose the heat, so it's a negative number. 19, when Q is positive. Okay, positive. Temperature went up, so it has to absorb heat. Endothermic. 20, Q is negative. Temperature had to drop. Okay, got colder. It's exothermic. But 2 parts. The system in 19 is endothermic, but then that means the surroundings had to cool down. 20, exothermic. The system released heat. Where did the heat go? It went to the surroundings. So the surroundings warm up, but the system has to cool down. So, again, think of 19 and 20, 2 sides of the coin. Something has to gain heat, something else has to lose heat. 21, Q represents heat or energy. The Q is calories. The Q is joules. The specific heat is calories per gram degree Celsius, or joules per gram degree Celsius. That's the C in 22. 23, delta T, change in temperature. TF minus TI, done in Celsius. "24, 5, 6, and 7 all go together. They're all part of this quote in this lab problem. They just do the steps, so I put them all together right underneath the problem, and then we separate them in 24, 25, 26, and 7. So first off, 150 milliliters. What's the mass? 150 grams. 1 milliliter equals 1 gram for water. It has a density of 1. Okay, it's the water that's gotten heated. It's the water that had the temperature change. So Q equals MC delta T, 150 grams of water times the 4.18 joules per gram degree Celsius times the temperature change. Okay, and in this case, the water cooled down. It lost heat because we put some ice in it. That's why it's negative 10,659 joules. It got colder. It lost heat. Okay, the water lost heat. Where did the heat go? It went into the ice to melt it. So the ice gets plus 10,000. But if we want to change it into kilojoules, we have to divide by 1,000. There are 1,000 joules in a kilojoule, 1,000 calories in a kilocalorie. So it's positive 10.659 kilojoules. And then if we want the heat of fusion, that would be Q divided by the mass. Remember that the CF and the CV are done per gram. So the 10,000 joules divided by 23 grams gives you your heat of fusion. Then we have a second one. This is like our chip lab. 50 milliliters of water in a can. We have the flaming Doritos in this case. Temperature of the water rose from 25 to 80. So we're going to go through those in 28, 29, 30, and so forth. 50 milliliters means 50 grams. Again, it's the water that got heated by the burning chip. So Q equals MC delta T. This one's in calories here. 50 grams times 1 calorie per gram degree Celsius times change in temperature. Gave us the 2750 calories. 30, we changed the calories little c into big C by dividing by 1,000. 1 gram of Dorito got burnt up. So we take our 2.75 calories per gram, since it was 1 gram. Now when we actually did that, most of you came out with like 0.2 or 0.3 to divide by. That's what you were supposed to do in the lab. And if you eat 50 grams of Doritos, how many calories would you consume? Notice that that's little c calories. So first we take the 2.75 calories per gram times 50 grams, that gives us 137.5 big C calories, and then times 1,000 little c calories. And then there's that same picture that was on the quiz. So again, if you'd done your review, that would have helped. Solid at 1, gas at 5, liquids 3. Technically speaking, 2, the ends of 2 have both solid and liquid, so you can't have one state at 2. 2 is the phase change, where it melts or where it freezes, depending on which direction you want to go. That's why in 36 we have melting and freezing. Boiling and condensing would be at 100. So 37, melting, evaporating is 4, condensing is 4, crystallizing would also be at 2. 38, melting and boiling are endo. To melt, you have to gain heat to melt it. You have to gain heat to boil. You have to gain heat to evaporate. On the other hand, you have to get rid of to freeze, get rid of to condense. And again, law of conservation of energy is how a calorimeter works. That was another question on the quiz. Since no heat is lost in the environment, all the heat from the hot item that cools down has to go into the cool item that warmed up. Any questions?